Simulink is a graphical design tool that can be used to model and simulate systems in many different application areas. For example, to simulate the temperature of a house over time, we need to create a model for the outdoor temperature. Let's explore the Simulink environment to see how we can create a basic model for this problem and run a simulation. First, we need to open Simulink. In the Home tab of the MATLAB toolstrip, click the Simulink icon. This will open the Simulink Start page. This page contains a set of model templates for different applications. It also provides access to product examples and recently opened files. Let's create a new model using the blank model template. Okay, now what? Since Simulink is a block diagram environment, we'll create a graphical representation of our system, using blocks as the main elements to build the model. In the simplest case, the outdoor temperature can be modeled by an average temperature plus a daily temperature variation. So, we need to begin adding blocks to our blank model. All available blocks can be found in libraries that group them according to their functionality. Let's open the Simulink library browser by selecting the library browser icon. The Simulink library browser displays libraries in a hierarchical list view. To see the blocks contained in a library, we select the library name. Blocks are listed in the right column. First, we'll add a block that represents the average outdoor temperature. In the Sources library, we select the Constant block and we drag and drop it so it's added to our model. After adding a block to our model, we are prompted to set the value of a specific parameter. We can also double-click the block so the block parameters dialog appears. Then, we replace each relevant field with a proper value. Here, let's set the constant value so it represents the average temperature. We can also edit the block name to something more meaningful. Next, we add a block that represents the daily temperature variation. Let's approximate the variation with a sine function. The sine wave block in the Sources library is the one we need. To better represent a small daily variation, we'll adjust the block parameters. Finally, we need the Add block from the Math Operations library. We now have the blocks, but how are they going to interact with each other? Well, we need to connect them with signal lines. Signal lines are used to carry the output of one block to the input of another when the model is simulated. To make the connection and create signal lines, left-click the output of one block and drag to the input of the other block. As we have the blocks connected in our model, we can simulate by pressing the Run button. But wait a second. How will we check the results of the simulation? It looks like we need an additional block here. Let's go to the Sinks library and add a Scope block, which will display the resulting signal with respect to simulation time. As before, we connect the block by dragging the signal line from the Add block to the Scope block. And we're ready to run the simulation. Now, that wasn't so bad, was it? Let's double-click the Scope block to view the results. And voila! We can now run the simulation and see the results. Notice that the simulation ran for 10 seconds. To change this, we would need to modify the stop simulation time. This value appears at the top of the Simulink editor. Once we change the stop time, we run the simulation again and check the results. That's better. Now, if only I could predict the weather.